In today's math lesson, we're going to write equations in standard form. Equations that are in standard form look like ax plus by equals c, where a, b, and c are your numbers. There are 3 rules that have to be met in order to make sure that your equation is in standard form. Let's find out what they are. The first rule is that x must come first in your equation. The second rule is that x must be positive. So x has to come first and x has to be positive. The third and final rule is that there can be no decimals or fractions in your equation anywhere. Example 1. Rewrite the following equation in standard form, where y equals negative 10x plus 2. Remembering that it is always a good idea to draw a line or a river through the equal sign of your equation so that you can determine easily the right side of your equation versus the left side of the equation, let's now begin the process of getting this equation into standard form. So we know that our end game goal is to have an equation that looks like ax plus by equals c, which means that this x term that's here on the right has to move to the left and be on the same side of the equation as the y. So as you have learned previously, to get things to move across the river or to the other side of the equation, we do the opposite of the sign that is there, and what you do on one side of the river, you do to the other. As a result, we end up with 10x, and this y is positive. So there is a plus sign right in between our x term and our y term, equaling 2. So we have to check the 3 rules to know if you're done with this process. So let's review. Rule number 1 was that x must be first. Yes, it is. It's the very first term. The second rule was that x has to be positive, and this 10x is positive. Good. And the third rule is that there can be no decimals or fractions anywhere in the equation. So this is set. We are in the format of ax plus by equals c. 10x plus y equals 2. So yes, this is now in standard form. And there you go. Example 2. Rewrite the following equation in standard form where y equals 9x minus 4. Since the river is drawn, let's begin our process of making this equation in standard form of ax plus by equals c. All right, so our x term needs to move across the river to the side of the equation with our y. By doing that, to make that happen, we need to use the opposite sign. Currently, this is a positive 9, so we will subtract 9x on both sides of the river, creating for us negative 9x. This y is positive, plus y equals negative 4. Okay, rule number 1 has been met. X is first. Great. But rule number 2 is still being violated. This x is not positive. So we have to make it positive. To do that, you're going to divide every term by a negative 1. That's all you need to use is a negative 1. The 9 itself, the absolute value of negative 9, is fine. But the negative, that's a problem. So we divide everybody by a negative 1. So a negative divided by a negative is a positive 9x. A positive divided by a negative is a minus a negative y. And then a negative divided by a negative is a positive 4. So is x first? Yes. Is x positive? Yes. Are there any decimals or fractions? No. Therefore, we have met all of the requirements to be in standard form, and we see that, yeah, the y is negative, but that's fine. The rule said only the x has to be positive. That's the one that we super care about for the sign. So there you go. Example 3. Rewrite the following equation in standard form where y equals 8x minus 10. Now that we've got lots of space, let's begin rewriting this equation to standard form of ax plus by equaling c. All right, so we need to move the 8x across the river. Let's do that by using its opposite sign. This 8 is positive, so we're going to subtract the 8x on both sides of our equation. As a result, we know that on the left side of the equation, we have a negative 8x, and our y is still positive, equaling a negative 10 on the right side of the equation. So x is first, there it is, but x is not positive. We have to fix that rule. We have rule number 1, but not rule number 2. To make this 8x a positive, we have to divide every term by a negative 1. We only do this if the x is negative. If it's not, if it's positive, this is a non-event. It's a moot point. Don't worry about it. A negative divided by a negative is a positive 8x. A positive divided by a negative is a negative y. And a negative divided by a negative is a positive 10. All right. X is first. Yep. X is positive. Yep. Hey, the y is negative. Don't care. That's just fine for standard form. And we have our c term there on the right side of the equation all by itself. And there you go. Example 4. Rewrite the following equation in standard form where y equals negative 7/3 x plus 10/3. To get this process started, let's look at how to get our x term on the correct side of the river, knowing that our endgame goal is ax plus by equals c. Our x term is currently negative, so to fix that, we're going to add it. We'll do its opposite sign, its opposite action. On the other side of the river, as a result, we know that we have a positive 7/3 x, and our y that is also positive on the left side of the river, plus our 10/3 on the right side. This is on the left, sorry. My left and right got mixed up today, didn't it? 7/3 x plus y on the left, 10/3 on the right. So x is first, yes. X is positive, yes. Oh, but we have a fraction. We have two fractions. Okay. So to get rid of the fraction, you are going to look at what's happening with the denominators. Well, these denominators are the same, which is great. That makes it easy. We are going to multiply every term by what the denominator is. This is going to cancel out our fractions, making this an agreeable standard form. What does that look like? It means I have 3 times 7/3 x plus 3 times y equaling 10/3 also times 3. So where I have 3's on a denominator, those were intentionally designed to cancel out. That was the whole point. Leaving us with a positive 7x. So here I really have to multiply 3 times y. Oh, well, that's not hard. That's just 3y. And my 10/3 times 3, well, again, my 3's canceled out. Okay. We have 7x plus 3y equals 10. X is first, x is positive, and we got rid of all of our fractions. So our equation is now in standard form. And there you go. Our fifth and final example. Rewrite the following equation in standard form where 1/8 x plus 9/4 y equals 3/5. In this particular problem, we can look at it and say, well, isn't it already in standard form? I mean, x is first, true, and x is positive, true again. But there are definitely fractions all throughout it. So this is not yet in standard form. It's coming along, but we still need to finish out this process so that we only have integers. We don't have any fractions. All right. So we looked in example 4, and we saw that when you have fractions, we need to multiply by a denominator to get rid of the fractions. And since our fractions have different denominators, we have to do this more than once. But let's see if there's a more efficient way to do this. The efficient way would be to say, hey, do any of our denominators have anything in common? Are they related, so to speak? You'd say, yeah, 8 and 4, they are related. 8 is a multiple of 4. And say, yeah, exactly. That's what I needed to hear. So we are going to multiply all 3 terms by our largest denominator first and see just how many fractions that gets rid of. So we have 8 times 1/8 x plus 8 times 9/4 y equals 8 times 3/5. All right. So what that does for us is these 8s cancel out there at the very beginning, which is great. So I know for sure I've gotten rid of one fraction, leaving us with 1x. And then we see that when you multiply 8 times 9/4, well, 8 times 9 is 72. And 72 divided by 4 is 18. Aha. We have gotten lucky and gotten rid of a second fraction. We could have multiplied by 4 first, and it would have gotten rid of this y fraction, but it would not have also gotten rid of the x fraction. So this multiplying by the largest was a nice twofer, so to speak. And then multiplying 8 times our 3/5, 8 times 3 is 24. 24 does not divide cleanly by 5, so we still have to tend to multiplying by 5 on all of our terms to get rid of this last fraction. So that's what we're going to do. We're going to get rid of this last 5 by multiplying this last denominator, this last fraction. I'm going to multiply everything by 5. Okay, let's see what it creates. So 5 times 1, that makes 5x, plus 5 times 18, that makes 90y. And then, as we did by design, 5 times 24/5, those 5s cancel out, leaving us with 24 in our final position. Okay, x is first, yes it is. X is positive, yes it is. And now we have also gotten rid of all of our fractions. And this equation is officially in standard form. So there you go.